Our galaxy, the Milky Way, is vast. It stretches across the night sky, a sprawling collection of stars, planets, and cosmic wonders that boggle the mind. It contains hundreds of billions of stars, many orbited by planets. These celestial bodies, each with their own unique characteristics, form a complex and dynamic system. The universe is even bigger, with billions upon billions of galaxies like ours. Each galaxy, a vast collection of stars and planets, contributes to the enormity of the cosmos. With so many stars and planets, it seems likely that life, even intelligent life, should exist elsewhere. The sheer numbers suggest that we are not alone, yet we have found no definitive evidence of alien civilizations. Despite our best efforts, the cosmos remains eerily silent. This deafening silence, this cosmic loneliness, is one of the most profound mysteries we face. It raises questions about our understanding of life and the universe. Why, in this vast and ancient universe, haven't we encountered anyone else? The absence of contact is perplexing and unsettling. This question has haunted scientists and philosophers for decades. It challenges our understanding of the cosmos and our place within it. It challenges our assumptions about our place in the cosmos and forces us to confront the possibility that we might be alone. The implications of this are profound and far-reaching. This essay will delve into one of the most compelling attempts to answer this question, the Great Filter Theory. This theory seeks to explain why, despite the vastness of the universe, we have yet to find evidence of other intelligent civilizations. In 1950, physicist Enrico Fermi posed a simple but profound question during a lunchtime discussion: where is everybody? This question wasn't just a casual musing, it was a reflection of a deeper scientific curiosity that has puzzled humanity for decades. Fermi's question emerged from a paradox that bears his name today. He was referring to the apparent contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations. Given the vast number of stars in our galaxy alone, many of which are similar to our Sun, it seems statistically improbable that Earth is the only planet harboring life. This question, now known as the Fermi paradox, highlights the discrepancy between our expectations of finding alien life and the stark reality of our cosmic solitude. The universe is unimaginably vast, with billions of galaxies, each containing billions of stars and potentially even more planets. The paradox is strengthened by the sheer scale of the universe and the vast amounts of time available for life to evolve. Over the course of billions of years, it seems likely that intelligent civilizations would have had ample opportunity to arise and make their presence known. If even a tiny fraction of stars harbor planets, and a tiny fraction of those planets develop life, and a tiny fraction of those life forms become intelligent, there should be numerous civilizations scattered across the cosmos. The numbers are staggering. With an estimated 100 billion stars in our galaxy alone, even the smallest percentage of life-bearing planets should result in a multitude of intelligent species. And yet, despite our best efforts to search the skies and listen for signals, we find nothing. No signs of advanced technology, no evidence of interstellar communication, no traces of galactic empires. There should be numerous civilizations scattered across the cosmos. The silence is deafening, leading us to question our assumptions and explore new possibilities. Yet, we see no evidence of their existence. No signals, no megastructures, no galactic empires, just silence. This profound silence forces us to confront the possibility that we might be alone, or that we have yet to understand the true nature of the universe and our place within it. The Great Filter Theory attempts to resolve the Fermi paradox by proposing that there is a significant barrier, a great filter, that prevents life from reaching a certain level of complexity or advancement, ultimately leading to its extinction. This filter could be a single, catastrophic event, or a series of hurdles that are incredibly difficult for life to overcome. The theory suggests that the emergence of intelligent life capable of interstellar communication and colonization is not a given, but rather an incredibly rare occurrence. This rarity could be due to the filter acting at any stage in the evolution of life, from the formation of the very first cells to the development of advanced technology. The first potential location of the Great Filter lies in the very origins of life itself. The transition from non-living matter to self-replicating organisms is a complex and poorly understood process. it's possible that the conditions necessary for this transition are incredibly rare, requiring a specific set of chemical reactions and environmental conditions that are seldom met. Even if life does arise, it might be incredibly fragile in its early stages, vulnerable to harsh environmental factors such as asteroid impacts, volcanic eruptions, or drastic changes in climate. The early Earth experienced numerous such events, and it's possible that on other planets, life is snuffed out before it has a chance to gain a foothold. Section 5. The long climb, from simple cells to complex life. Assuming life survives its infancy, the next hurdle it faces is the development of complexity. For billions of years, life on Earth remained in a single-celled state. The evolution of multicellular organisms was a major leap forward, requiring cells to cooperate and specialize in unprecedented ways. This transition might be a significant bottleneck, requiring a series of evolutionary innovations that are statistically improbable. It is possible that on other planets, life remains stuck in its single-celled form, unable to make the leap to greater complexity. Section 6. The intelligence threshold. A filter we've passed? The emergence of intelligence, as we understand it, is another potential location for the Great Filter. While life on Earth has existed for billions of years, it was only relatively recently that intelligence evolved to the point where we can ponder our place in the cosmos. This raises the question, is intelligence an inevitable outcome of evolution, or a chance occurrence, a product of specific environmental pressures and random mutations that might not be replicated elsewhere? If intelligence is rare, then we might have already passed a significant hurdle in the Great Filter, making our existence all the more precious. Section 7. The existential threats. Are we doomed to fail? However, the Great Filter might not be behind us. It's possible that intelligent civilizations are inherently self-destructive, prone to wiping themselves out through nuclear war, environmental devastation, or runaway technological advancements. This possibility is particularly concerning given our own species' capacity for conflict and our impact on the planet. If this is a common trend for intelligent life, then the Great Filter might lie ahead of us, a grim reminder of our own mortality and the fragility of civilization. Section 8. A filter behind us or a universe yet to bloom. The Great Filter theory offers two broad possibilities. Either we are incredibly lucky to be here, having overcome incredible odds, or we are facing an existential threat that will ultimately lead to our demise. This theory is a cornerstone in the search for extraterrestrial life and understanding our place in the cosmos. It forces us to ponder whether the silence we observe in the universe is because intelligent life is exceedingly rare, or because it tends to self-destruct before it can reach out to the stars. Both possibilities are profound and have significant implications for our understanding of life in the universe. If we are indeed alone, it means that life is a precious anomaly, a rare gem in the vast expanse of space. This would make our existence even more extraordinary, and our responsibility to safeguard it even greater. On the other hand, if the filter lies ahead, it serves as a stark warning that we must be vigilant and proactive in overcoming the challenges that could threaten our survival. If the filter is behind us, then we might be one of the few or even the only intelligent species in the galaxy. This would imply that we have already navigated through the most perilous stages of development, such as the emergence of life, the evolution of intelligence, and the avoidance of self-destruction. It would mean that our future is potentially boundless, filled with opportunities for exploration, discovery, and growth. This realization would place a tremendous responsibility on our shoulders to protect and preserve life as we know it. We would need to act as stewards of our planet, ensuring that we do not squander the unique chance we have been given. This would involve not only protecting our environment, but also fostering a culture of peace, cooperation, and sustainable development. If the filter lies ahead, then our time might be limited, a sobering thought that underscores the urgency of addressing existential threats and ensuring the long-term survival of our species. This could include mitigating the risks of climate change, preventing nuclear war, and managing the development of advanced technologies. By recognizing these potential dangers, we can take steps to navigate through them, ensuring that humanity not only survives but thrives in the future. Section 9. Our search continues. In the shadow of the Great Filter. The Great Filter theory, while sobering, should not discourage us from searching for extraterrestrial life. On the contrary, it should motivate us to intensify our efforts to seek answers to these fundamental questions about our place in the universe. Every new discovery, every advance in our understanding of the cosmos, brings us closer to unraveling the mystery of the Great Filter. Whether we find ourselves alone in the universe or part of a vast, interconnected web of life, the search itself is a testament to our curiosity, our ingenuity, and our enduring hope of finding others out there in the vast cosmic ocean.